Peter Witzke from EuroCARE and working for quite some years with a CAPRI model, mostly to carry out some form of baseline or impact analysis with the system, and I will give you the introduction of this system. We will start with some core characteristics, then show you a little bit of the history of the model development, then some questions that have been asked also before on database will be addressed briefly. Of course, CAP strategic plans and other impact assessments to move on then to a specific scenario example in line with the analysis that have been carried out by our Hungarian colleagues. So we will split the presentations in two parts. Basically, I will do the introduction, and then later on we will hand over to the colleagues Tools4CAP from the Hungarian team. And I have to say, I'm quite maybe to give these remarks directly in the introduction, because this was the case study was also an attempt to try out whether it works basically to transfer the knowledge on actually using the model to a national team that was not yet fully partner of CAPRI network, but the collaboration evolved based on one previous project, and now I'm so far quite happy the way it has evolved, because I see that the team in Hungary is able to run their own analysis and to make their own assessments, which at the beginning, I have to be honest, I didn't expect to work out that well. Okay, so we'll go through the first block of the presentation with a number of characteristics of the system. There is a website where you can see more details. Key elements are that it is a global model. Embedding the analysis in the global context is important for some questions. It has, of course, a clear focus on agriculture, and it has a focus on Europe, on the European Union. It's kind of Euro-centric, so we have more details for Europe than for other regions in the world. Basically, the system is designed for two ways of application. The standard is this impact assessment, as we have heard before, of various policies, maybe agriculture, environmental, or trade policies. Agriculture and environmental policies would be, of course, those which are most relevant for the CAP strategic plans. And for that purpose, the core of the model is basically linking two components, supply modules, a set of programming models covering the European NUTS2 regions, which offer a lot of technical detail, and therefore also the linkages to environmental aspects. Plus then the global market model, which provides the embedding into the global framework and permits to have endogenous prices that can be fed back to the supply models, and thus pick up in this way the price feedback from markets. That's what we will see later on also in the example that we show. I think probably almost half of the applications of CAPRI have to do with various variants of Outlook work. So providing a baseline for other analysis, which is following up then. And in this process, well, Thomas mentioned it from the other angle, providing the information to well, the different client models, so to speak. Of one of them is CAPRI. So CAPRI would start its own baseline based on the database it is maintaining and developing and updating. So from that we can compute simple trends, but simple trends are fairly stupid methodology for projections. So we are happy that we can pick up information from the medium-term outlook activity, which we have heard is an activity that involves several steps and brings in the expertise of various market experts as well. It's something that we cannot provide with a team of modelers which simply do not have the time to continuously monitor single markets. So we pick up information from some external tools, and we impose technical consistency, and the result of that is then our baseline, which is disaggregated into the regions and possibly also into a finer breakdown of activities and products. Then the models that we take as providers of information, such as AgLink. Okay, these are the two main application modes of the system. The system has a longer history, and it was developing typically in response to some policy development. In the starting point was at the time of the first reforms of decoupling and the Agenda 2000 reforms, moving on to various others. Right now, one of those in the middle, trade reforms, with in particular the Mercosur agreements. They have been on the table for many years, then they have disappeared again, and sometimes they are popping up, like now it is the case. So the system has been responding to policy developments over time. Now, well, that's our topic here. The integration of the CAP strategic plan is what is the topic of this academy session here. A little bit of background on the database. We use different sources, and well, different sources typically they are not consistent with each other, and they are also not complete over time. So we need specific modules. It's a modeling activity on its own to integrate these different databases such that they are internally consistent, even though then perhaps a bit deviating from the original, what we would call raw data sources that we find from the statistical agencies like Eurostat or Farostat, which are of course the most relevant and provide the core data for our system. But this has to be supplemented for various special topics, but also for our parameters that are needed to run the model, which sometimes is coming from data sources like SFEDN, which or farm sector survey, which is used for our input allocation. We have various previous studies. Sometimes we were involved. Sometimes we borrow the parameters from other groups which have done an estimation, like for the demand system, which will be updated shortly. And we have other information from other models like the Mitera and Gaines model, also YASA based. For the policy data, which is one of the key topics here, we fortunately rely often on collaboration with JRC, who of course have the expertise, but also the good contacts to get in touch with respective units of the Commission, like DG Agri. And this is extremely helpful to be simply relevant in terms of the inputs. I think I mentioned already this the information flow from other models where we are linking for the long run, typically to GLOBIOM, that has been presented. Just for the medium run, because that's where this is the strong points and the focus of these models, we would give a higher weight to the AgLink projections. And we also pick up specific information, like from the energy models, specific energy models primes. I think I move on. immediately to the CAP strategic plans, which is what is right now under preparation. As I mentioned, we are extremely happy that JRC has taken over a good and a major part of the work to organize this information in a standardized manner in this so-called master file, where different measures are organized according to several criteria, such that we are able to access that information and do not have to go to different formats. So we receive this information in a uniform format. Nonetheless, it is really, it has been a challenge that the disaggregation, the heterogeneity across countries has increased vastly with this, in this phase of the CAP development, where we have to consider thousands of different measures under the broad categories of direct and coupled support, eco schemes, climate and other rural development measures for the areas under national constraints. And we have also other policies like investment support that we are not yet really covering in CAPRI, because the system is not designed for that purpose, being a so-called partial equilibrium model, where we do not really model capital formation. I think also in this, it is fair to say that on labor and capital, the other models which are in iMAP, like Magnet, have certain advantages. So we try to make use of these complementarities. But for the details of these CAP strategic plans, certainly CAPRI is doing, at least we try to do a good job to really take into account this variety, picking up the different information on the planet unit amounts with their average, maximum, minimum amounts and ceilings, things which have been also present in the previous generation of the CAP implementation, but not in this, let's say, heterogeneous and diversified form. What is, I would say, in our case, a bit qualitatively new step is to take into account in more detail the good agriculture and environmental conditions in a kind of explicit form, linking this to various mitigation technologies or farming practices, which are then specific in the system, whereas I think our previous treatment of the CAP was a bit more generalizing, so that there is a lot of progress underway, but it brings also along with it a lot of additional details to handle. So this was quite a longer process, which is still ongoing. The standard version that we will be using and showing in our example later, and that also Zolt will show from the Hungarian team, is relying on the standard version. But shortly, I think probably in the course of January, at the latest, I think we will transfer this specific detailed version with coverage of the CAP strategic plans into the standard version, and then it will become available for all projects easily. I think I move on now to, well, what's the purpose of the modeling activity, to obtain information on some outputs of relevance, and this is typically, this is in falling into two areas. So the classical, we could say, agriculture outputs from the production sphere, like area use, yields, animal herds, moving on from there to the market balances, including trade, so interrelationships with other countries are covered. And of course, when we are at the markets, price formation gives us the prices, as I mentioned before, which together with policies and so the premiums, direct payments, determine farmers' income, which is one of the output variables of the system. These would be we could say, classical agricultural policy variables of interest, but this is since many years supplemented with various environmental indicators like the greenhouse gas emissions and also carbon sequestration from land use change. We have nutrient balances to also assess nitrogen leaching. And there is also a specific version with more disaggregated information on irrigation, which is not used in the application that we have shown here. And it is also fair to say that I think in terms of the detail regarding irrigation, GLOBIOM has much more to offer than CAPRI. Okay, we move on to the impact assessment, which is really one of the main applications of the system. And well, CAPRI has been used in various past impact assessment, very often together with GLOBIOM, like in the most recent applications for the 2040 climate targets plans, where if we are doing this in a joint network, we can exploit a little bit the different strengths of our systems, where GLOBIOM evidently is better able to handle LULUCF as in total, including the forest sector and maybe agriculture in the details, can be better reflected in the CAPRI system because it has a longer tradition there. So the examples that we show will be about impact assessment, and it is good to know then, or to be aware of that, what it actually is. So we are in this simple graph, we are just showing the ex post period there, which is then continued with the blue line, a few intermediate projection points, which is quite typical. We are not applying the model on an annual basis. It would be possible, but it would take awfully long, so we wouldn't typically do this. This baseline then is modified in some way, either by some specific variation of the baseline policy, like when we could have a baseline without the CAP strategic plans and then we introduce them, or we could have a baseline including the CAP strategic plan and then we remove the CAP strategic plans, or we modify them. Then the difference of these two results, which would be simulated then with a system, that's what we call impact. So, and these drivers of impacts, they can be policy, but as we have seen in the previous example from GLOBIOM, it is often also climate change. So which we have also run frequently. So we are looking at the differences between two scenario runs, and that is what we consider impact. It is not the difference from the historical period to the final simulation. That is maybe what is often specified in policy targets that we want to improve against some observed point, recent observed points, say around 2020, or for the climate targets, 1990 as a famous reference point. But for impact analysis, we are looking at the differences at the same year. And here I'm now kind of making the transition to the subsequent detailed presentation by Zsolt on from our Hungarian team. And we have modeled a variant of that, where we are removing the voluntary coupled support for dairy, which is then evidently providing economic pressure to the dairy sector, which is therefore declining. So milk production tends to decline, and this will have impacts on prices. And in contrast to the analysis that we will see later on, where voluntary capital support for dairy is removed in the whole EU, here we are considering a specific variation to have that policy only in Hungary. This may be a typical application of a system like CAPRI if it would be done on the national level, because then typically decision makers in the policy process would try to fine-tune their specification of the CAP strategic plans, but only in their own country. So in this context, this version of the modeling, it fits quite well. And well, in this context, if that voluntary capital for dairy is only removed in Hungary, then it is clear that we see the impacts on supply in Hungary. And in our case now, we see also that in the circuit with the circuit numbers, we see that there are effects on the milk prices. If voluntary capital support in the fourth rightmost column is removed, then we see an increase in milk prices. Quite intuitive. Whereas if we run the whole system, which is possible, without this market feedback, then, well, we could say almost by definition, the prices are kept constant. So if we display the prices that are resulting from the two, from this reference scenario and this policy scenario, if we would run it only with the supply models, then of course the prices do not change. We do not see anything. This way of applying the system may nonetheless be attractive because it is much faster, it is easier, it is less prone to any technical difficulties. So for some questions, it may be useful to run the system in a simplified mode. But as usual, if we simplify, then this can have drawbacks. We lose also some aspects. And here, what we are losing, if we do not consider the market feedback, is that the prices are changing in this scenario. And then this translates then, of course, into our results. If we would run this scenario, so basically removing the voluntary capital support for the dairy sector, then of course income in the dairy sector, it will decline. That's pretty evident. If we would analyze this scenario without the market feedback, so with prices maintained constant, then this would mean about an income loss for the dairy sector of 6%. If we consider that, as we saw previously, that the milk prices, raw milk prices would increase, then of course that income loss is moderated. So just as an example, depending on how the system is applied, it can give a more complete or less complete answers to the questions. But sometimes it is also of interest. That's what we wanted to show. It is of interest to have the flexibility to run the full system or just parts of it. And with that, I'm more or less done with the presentation of the basic CAPRI system.